Hello, how are you? It's Calvin again here. I'm happy to join you again to continue the lecture tutorial on VIC. We have dealt with part 1, dealing with the VIC structure. Now we are going to see the model data requirement, where we source this data and some of the applications that we have in the region that are documented. The model data requirement for this particular case, we need a global parameter file. This is the engine that really do the simulations, where you control it. You put your time step, you put out the model you wanted to simulate your system. Then the second part of it, we are going to look at the meteorological forcing files. That is the data that it needs, the climate data that it needs. It needs soil parameter data. And looking at this particular system here, you'd see the soil parameters, vegetation library, meteorological forcing file is being controlled by the global parameters and the snow elevation band into the VIC model. And we also need to know something about the elevation. The topography data is key here. We need observed data, and the observed data is in situ measurement. Now you need to understand that most of this data and parameters are available from NASA satellite observation of Earth system modules, and I've defined and given you where this data can be obtained, and we look at them in one by one or in detailed where we need them. So one of the input files that VIC requires are global parameter files, and I've stated earlier these files defines the location of output and the input files where they're located within your system, and also it defines something about the start and end here of your simulations, the time steps, the number of layers that you want to simulate on the soil. So all these, as I stated earlier, are user dependent, and in this particular case we are doing the simulation from 2000 to 2019 and all running from January to December. Now the soil parameters file are obtained from what you call the World Soil Harmonized, and this World Soil Harmonized provided some documentations where that can be found and where this data can be found, the description of the data. But essentially what it does is that assigned an ID to each grid cells on the basis of their location in terms of longitude and latitude, and it defined the soil hydrological and thermal parameters for each grid cells, like we have seen in, for example, in a curve number system, you have class A, B, C, and D. It also defines something about the initial soil moisture condition, because you have to know your initial state of the system before you run your simulations. And there are different around 15,000 different soil mapping units from combined regional, nationals, in this worldwide, and these are available in a in 1 kilometer raster file from World Soil Harmonized that was organized by FAO. And these soil parameters that we need, the model needs, in terms of organic carbon, pH, water storage capacity, soil depth, ion exchange capacity of the soil, and the clay fractions. The total exchange nutrients, lime that you need, the salinity level, textural classes, and all the soil parameters, the soil data should contain all these parameters that the model needs. And in terms of the meteorological forcing files, the model needs minimum surface temperature, you need maximum surface temperature, you need precipitation, we need wind speed, and annual precipitations for you to enable you to initial soil moisture conditions. Now the subdale is necessary for the simulations, and that is when the energy balance mode can be operated. In terms of vegetation library, if this library or this type of data contain the information that defines the land cover, the vegetation classes, fraction of the grid cell that is covered by the vegetations. You need something about the leaf area index. We say the canopy plays a very key role here, and you need something about the albedo, the energy in terms of knowing something about the solar radiations. The routing depth and the distribution, this is user defined, and the height of the surface wind speed, either in 2 meters or 10 meters. The FAO Penman Monteith recommend 2 meters height. The vegetation library essentially supplements the vegetation parameters file. It defines the parameters for all the land and the vegetation classes that your model need to undertake the simulation for your watershed. In terms of elevation data, the VIC model grid is a grid-based, which means all the information should go in terms of the gridded. It is user-specific in terms of the number of elevation bands that you're going to define. We have seen talked about something about snow and elevation band, and how the temperature transition is playing there. And you need to know that each elevation band is simulated separately, and the elevation data is useful in determining what the snow band is. I've provided some table there that how the information file is coded into the model. In terms of the application, in our current source, we are applying the model for stream flow monitoring and focusing for Rufiji Basin, and we are calibrated the model to some specific locations where we had some good observed data, and this is how the information is coming out. For example, there's a very good simulations at Mwenda station at 1K A31, and pretty not really good calibration at 1K 59. I've included those just to have a more understanding of where we are heading to with this modeling work. This model of VIC has been used in Haia River Basin to determine the irrigation water requirement and run various scenarios to help in the management decision. So it can help greatly in management decision tool in terms of the watershed management and the planning purposes. It has also been used to determine the natural flow conditions by the US Bureau of Land Reclamations for Colorado River. For water supply to determine the flow conditions. So that is another application that the model has been used, and this is some of the results that they obtained, which are pretty really good results. The model has been also used by FuseNet in their land data simulations, or what we call GILDAs, Nicholas, and which satellite and the ground-based data are all ingested into the land data simulated model, and based on the surface and energy balance, water resources component like precipitation, evapotranspiration, soil runoffs are derived for the system, for the famine early warning system, or what we call the FuseNet. Another application is in the flood and the drought monitoring. The amount of water that's available within the river system can tell you also something about the drought conditions within this. And in this particular case, the Princeton University used the model with derived stream flow based on the TRM and multi-precipitation for the period of July to come up with that global map on a global scale. I've provided you with some resource materials that probably will be very useful for you. The current VIC website, the routing model, the GitHub where most of the information and the developments are being placed, and some of the references that you can refer to when you have the time or something you don't understand. We'll always be on standby to help where you don't understand. You can just put it in our discussion box and we'll respond to it immediately. Otherwise, thank you so much. Really appreciate your time. And I pass you over now. We are going to look into the data, the hands-on training or on the data processing preparations and how to do the deep VIC model simulations. Thank you so much.